military planners view mountain passes as natural choke points, narrow, defensible corridors controlling movement. And the extreme topography of the Himalayas creates some of the most unforgiving physical barriers on the planet. But these specific high-altitude routes come with a severe operational constraint. The sheer volume of snowfall forces a mandatory closure of these roads for 6 to 7 months every single year. When winter hits, the snow physically severs entire regions, like Lahaul Spiti and Ladakh, from the rest of the Indian mainland. On this topographical map, the Indian military operated under a specific assumption, marked by this 4,000-meter elevation line. Below it, they maintained winter posts. Above it, they left vast, unheld gaps, believing the environment was too hostile to support an invasion. Relying on the weather to act as a natural guard turned this formidable mountain barrier into a massive, unmonitored strategic blind spot. In May 1999, Pakistani forces used that exact blind spot against them. While the main passes were still choked with snow, intruders slipped directly into those unheld gaps and quietly entrenched themselves on the commanding heights. The Indian military was caught completely off guard. They were forced to rapidly deploy units into the high-altitude freeze before many soldiers even had access to specialized glacial clothing. It triggered a desperate logistical scramble to move troops from the valley directly into the Kargil sector, before the main routes, like the Zojila Pass, had naturally thawed. Pushing the intruders back out required brutal, uphill infantry combat in thin air, supported by thousands of heavy artillery shells to batter the rocky peaks. The Kargil conflict proved that the extreme elevation was no longer a reliable shield. The geography itself had been weaponized. After the war, the Kargil Review Committee was tasked with figuring out how to physically secure the border moving forward. One proposed strategy was called Siachenisation. This meant permanently manning and supplying every single gap along the high ridges, straight through the lethal winter months. This visualization shows why the committee rejected that approach. On one side, the financial cost of sustaining winter logistics climbs exponentially. On the other side, deploying soldiers across a 168-kilometer stretch of these peaks creates a terrifying projection of weather and avalanche casualties. If the military couldn't survive on top of the mountain passes, the only strategic alternative was to drill straight through the rock beneath them. Civil engineering became a strategic military imperative. The new objective was to stop fighting the surface elevation and simply bypass it entirely. This led to a multi-billion-dollar tunnel initiative, highlighted by the 9-kilometer Atal Tunnel and the even more ambitious 14-kilometer Zojila Tunnel. Grinding through the core of the Himalayas at these altitudes requires massive mechanical force, utilizing specialized tunnel boring machines to chew through solid bedrock. But the geology is often unstable. Engineers frequently hit permafrost, sections of ice-rich soil that immediately soften and collapse the moment they are exposed to the heat of the drilling equipment. This schematic details the primary countermeasure. Advanced systems pump freezing agents through pipes directly into the surrounding rock. This artificially locks the unstable earth in place, allowing the drill to safely advance. Once the rock is cleared, the tunnels require massive longitudinal ventilation systems to push breathable oxygen through the corridor, keeping the air safe for running combustion engines at 3,000 meters above sea level. Mechanical interventions designed to conquer nature's most hostile environments. Completing these massive engineering projects has a direct, measurable effect on physical travel in the region. The old route was a 49-kilometer path, twisting over the mountain. The Atal Tunnel replaces it with a straight 25-kilometer line through the base. That geometric shortcut drops travel time from 5 hours down to a predictable 30 minutes. The upcoming Zojila Tunnel applies the exact same mathematics, projected to cut an unpredictable 18-hour journey down to a reliable 6 hours. By bypassing the surface elevation, the winter gap permanently closes, allowing 365-day, year-round connectivity for the first time in history. Militarily, supply chains can now flow continuously to the borders of China and Pakistan, completely independent of the weather. This guarantees rapid deployment capability at any point in the year, removing the physical window of opportunity that allowed the Kargil infiltration to happen in the first place. The civilian benefits followed directly behind the military ones. The newly opened routes are driving double-digit GDP growth in the region, bringing in year-round tourism and creating reliable transit for agricultural exports. Himalayan communities that spent half of every year completely stranded are now tethered directly into the mainstream Indian economy. By deploying world-class engineering against its most brutal geography, India is erasing a historic strategic vulnerability and forging an impregnable, all-weather strength.